Welcome. In this video, we're going to continue to discuss right triangles and how we can use the Pythagorean theorem to find missing side lengths. Our first objective today remains understanding that the Pythagorean theorem is just a formula or an equation that allows us to find a missing side length for a right triangle if we know the other two sides. The formula is a squared plus b squared equals c squared. It works for any right triangle, but the important thing is c squared, the biggest variable, always has to be represented by the hypotenuse, the biggest side of the right triangle. That means a and b, which we're going to call the legs because they form the right angle, the short sides are going to be added together after we square them, and it will have the same value as the long side squared. We could rewrite this equation or transform it to say c squared minus a squared is equal to b squared, and as we'll discuss below, that can be helpful to use sometimes. The first example we're going to look at, this red triangle, which has side lengths of 24, 32, and an unknown, is a right triangle, so we could use the Pythagorean theorem. The important piece is to figure out which side is the hypotenuse. Which side do you think is the hypotenuse? Hopefully you realize that the unknown side for the red triangle is going to take c, the hypotenuse, because that's the longest side. It's facing the right angle. That means a and b are going to go in for 24 and for 32, the two legs or the shorter sides. Go ahead and try to figure out what the missing side length is by pausing the video and working out the red side. Welcome back. Hopefully you chose to use the formula a squared plus b squared equals c squared. This, the classic form of the Pythagorean theorem, is best to use whenever we don't know the longest side, and that's because the c is isolated. It's already by itself. So I'm going to use this formula whenever I don't know the longest side because it's set up for c, and I'm going to use this formula whenever I don't know a short side because it's set up already to solve for a or for b. In this case, we go ahead and we substitute in for a and for b because those are the two variables we know. We replace a with 32. We replace b with 24. On a problem with big numbers like this, they'll almost certainly give you a calculator, so we can figure out 32 squared is 1,024. So we'll put that into our equation. 32 squared made 1,024. And 24 squared, or 24 times 24, should give us 576. That's still equal to c squared. With the last two steps, which are going to be add those two numbers together, 1,024 plus 76 leaves us with 1,600, which is equal to c squared. Hopefully by now you understand the last step we learned in 8th grade. What is the inverse operation of squaring a number? It's to take the square root. So I perform a square root on both sides of the equation. And the reason I'm doing that is because the square root of c squared, two inverse operations, is going to leave us with c on the right side of that equation. And we know that the square root of 1,600, if you knew the square root of 16 is 4, you might know the square root of 1,600 is 40. If I didn't know that, I could use a calculator and ask what's the square root of 1,600. It's 40, because 40 times 40 is what gave us 1,600. I look at this triangle, 40 seems like a reasonable answer with this side at 32 and that side at 24. Now, take a look at the blue triangle. Go ahead and try to figure out, by pausing the video, what is the missing side length, or x. Welcome back. Hopefully, you realize that for this problem, we don't know one of the short sides. That's because the longest side, c, that's facing the hypotenuse is already known. It has a value of 4. So we know one of the legs, a, could be equal to 3, but we don't know the other leg. This missing side, x, is going to be taking the place of b, one of the legs in our equation. I could use this formula, a squared plus b squared equals c squared, but whenever I see that the b, or the a, is the unknown side length, the shorter side, I use this formula because it's just a little easier. I'm going to go ahead and substitute in the two variables I know. C is going to get replaced by 4, and A is going to get replaced by 3. And now you can see why we prefer this formula for the legs, or the unknown, or when an unknown side is a leg. It's already set up to solve for B. The two variables we do know are plugged in on the same side or gathered on the same side. equation. 4 squared gives us 16, 3 squared gives us 9, and that's still b squared. When I do 16 minus, I'm left with 7, and that's equal to b squared. From back here, we know our final operation is to take a square root from both sides. So when we square root both sides to leave ourselves with b, we know b is equal to the square root of 7. Pause the video. Is the square root of 7 a perfect number? A perfect square? If not, how can we round it to the nearest hundredth or to the nearest thousandth? Welcome back. Hopefully you realize that square root of 7 is not one of our perfect squares. It's going to make an irrational number, so we have some options here. We could leave our answer as a radical. We could write it as the square root of 7. Or we could write our answer very exactly. We could say the square root of 7 is equal to 2.64575. Put a dot, 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 and that tells us a pretty accurate estimate, and the dot, dot, dot tells us it keeps going. If we're asked to round to the nearest tenth, that would be to the first place. We would just say b equals 2.6 if we round to the nearest tenth. If we round to the nearest hundredth, then we would be saying b is equal to 2.65. The reason for that, 2 places for the nearest hundredth, but the 5 tells me I need to round up the 4 to 5. Finally, if I said to the nearest thousandth, we would have to say that b is equal to 2.646. The reason for that, nearest thousandth is 3 decimal places, 645, but I got to round up to 646 because this 7 is big